Hey guys, and welcome to Histograms and Data Distribution Notes. So we have a little bit of vocab to get through first, and the first one is frequency, which is just the number of times a piece of data occurs. And then we also have relative frequency, which is how often something happens divided by the total number of outcomes. Alrighty, so to learn about histograms, a histogram is a graphical display that subdivides the data into class intervals called bins. B-I-N-S. And it's going to use a rectangle to show the frequency, the number of times a piece of data occurs, of observations in those intervals. And unlike a bar chart, however, the bars in a histogram touch one another. An empty space between bars represents a break in data values, meaning we don't have any data values for that interval. And histograms are really useful when working with large sets of data, but a disadvantage of histograms is that they do not show individual values. Alright, so we're going to begin today by learning how to draw one. Alright, so we have this lovely little example, test scores out of 100. So I want you to look at all of your test scores. Alright, so we're ranging from, I think the lowest I see is a 59. And the largest I see might be, so far it's a 91. Ah, we got a 95. Okay. Alrighty. So I think I'm going to go 55 to 64. I think I'm going by nines. 65 to 74. 75 to 84. 85 to 94. And 95 to 104. Now, these intervals will usually be given to you. You won't have to create them yourself, which will make things a little bit easier for you. Alright, so now, if you see a number, including or in between 55 and 64, you are going to write a tally mark. Alright, so 55. Actually, the easiest way to do this is to go 92 belongs in this table, and then cross it out. And 84 belongs right here, cross it out. 95 belongs here, cross it out. 77 belongs here, cross it out. 74, 80. That way you're not having to search over and over and over. Once you have your intervals, this is how I would do it. 66, 73, 68, 90, 78, 64, 72, 78, 76, 65, 59, 71, 77, 92, 91, 89, 74, 76, and 90. Cool. Alrighty. So now we have our lovely chart over here that we get to draw our histograms. So I'm going to say test scores. And the way that they're going to do this, the easiest way, is to count up your tally marks. So for 55 to 64, I have 2. For 65 to 74, I have 5, 6, 7, 8, 9. 75 to 84, I have 5, and then plus 3 gives me 8, 5, 6, and then 2. Alrighty. So now for our bins, we're going to go 55 to 64. And then I guess I'll do a different color now. 65 to 74. So I'm just using my intervals as my bottom piece, okay? 75 to 84. 85 to 94. And then 95 to 104. Right. And then on this row, this is where we want to have our tally marks. And so I'm going to go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. And so for 55 to 64, we had a frequency of 2. So you're just going to draw that bar graph right there. Okay? Or, sorry, not a bar graph, but that bar, that bin. And then 65 to 74, we had 9. So we're just going to continue this line right here. Create our bin of 9. And then 55 to 74, we had 8. And then 85 to 94, we had 6, which is right here. And then finally, 95 to 104, we had 2. And that is how you draw a histogram, okay? I don't actually think that you're going to be asked to draw one, but it's good to know how histograms are made. That way, hopefully you can understand them a little bit better. Alrighty, so once you have all of that graphed, we're going to move on to trying to understand a histograph. Alright, so these are the books read over summer break. So the first question it asks are how many students are surveyed? Alright, well, when you're looking at how many students are surveyed, you got to look at your bins, okay? You got to look at the frequency, the number of times, okay? So, right here, we had 7 people read 0 to 3 books, okay? And then we had 9 people read 4 to 7 books. And right here, we have 6 people who read 8 to 11 books. And then we had 4 people read 12 to 15 books. Okay? So, how many people total were surveyed? You're just going to add up your frequencies, which in your calculator you'll do, it's going to give you 26 students. Alright? Now we need to find the median and the lower and upper quartiles. This is kind of difficult, alright? Because we don't have those individual values. Now, one way that I have seen people do it is they do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so one way that I've seen people do it is they list out the number of people in each bin, and then they go 1, 26, 2, 25, 3, 24, 4, 23, 5, 22, 6, 21, 7, 20, and then 19, 8, 18, 9, 17, 10, 16, 11, and then 12, 15 to get your median. Okay, that's one way to do it. Okay, but honestly, you can get really, really confused going from the number of bin, because even right here, when I had to change, let's see, I think I was about right here, you want to go to the top when you're going this way, but instead we got to go to the bottom. So that can be really confusing. You can do it that way, but you're going to get, a lot of people are going to get confused. You might be able to handle it, but I know I had a very hard time learning it that way. So instead, there is a different way that we can do it, all right? So to find our median, which if you remember is Q2, our Q1 and our Q3, we're going to take our total number of students, all right? And we're going to divide it by 4. So let me knock this down a little bit, that way you can see my full paper. So 26 students divided by 4 is going to give us 6.5, okay? So then, to find our Q1, we are going to do 6.5 times 1, which is going to give us 6.5. To find our Q2, we're going to do 6.5 times 2, which is going to give us 13. And then we're going to do Q3 equals 6.5 times 3. You can remember it because Q1 times 1, Q2 times 2, Q3 times 3. The reason we don't have to do Q4 is because it's going to give us 26, alright? That's 100% of our data. We're not looking for 100% of our data. Anyway, this is going to be 19.5. So then, you would look to see where these numbers fall, alright? So, right here, for Q1 we have 6.5. Well, 6 and 7 are both in Q1, or sorry, are bin 1. Therefore, Q1 is going to be 0 to 3, our bin number, okay? And then 13 for Q2, our median, is right here. So that's going to be in bin 4 to 7. And then our Q3 is 19.5. 19 and 20 are both right here. That means that it would be about right there, which is in bin 8 to 11. Oh, and I forgot to circle over here for 6.5. Alright. Now some of you guys may be asking, what if our Q1 had been 7.5? Well, that's actually a little bit tricky, but so we only go up to 7 right here. If it had been 7.5, it would have been 4 to 7, because this only includes 7 people. Like 7 is the maximum number we can get from this bin. Okay? Alright. So, if you're good on that, let's move to the back. Alrighty. So, Stephanie is a student at Mathopolis High School, and these histograms give information about the number of hours spent watching TV a week by each of the students in Stephanie's homeroom and by each of the students in the 9th grade class at her school. So, this is Stephanie's homeroom, because it says so right there, and this is the whole 9th grade class, and it's the weekly hours of TV viewing. So here we have hours of TV watched weekly, and here we have the number of students surveyed. Alrighty? So, it says to compare the medians, the lower quartiles, the upper quartiles of the data in the histograms. Alrighty. So, it wants us to do, Stephanie's homeroom is blank the whole 9th grade class. So it wants to know if it's larger, lower, or equal to. So that means that we need to find the median and the lower quartile and the upper quartile for both of them. Okay? So the first thing that we need to do is count how many people there are. Alright, so here there's 11, and then here there is 6, and then here is 4, and here is 2. So 11 plus 6 plus 4 plus 2 is going to give us 23. And we need to divide that by 4. Okay. which is going to equal 5.75. Alright, so for Q1, we do 5.75 times 1, which gives us 5.75. For Q2, which is our median, 5.75 times 2, which gives us 11.5. And then for Q3, 5.75 times 3 gives us 17.25. Alrighty. Okay. So those are our special numbers. Alright. And we need to figure out where these numbers lie in this histogram. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So that's our 11 people. I'm going to zoom in a little bit. There we go. And then 12, 13, 14, 15, 16, 17. Okay. 18, 19, 20, 21, and then 22, 23. Awesome. Alrighty. So I think it's helpful to go ahead and list them out like that. You may not. It is kind of up to you how you decide which number goes in which bin. But I think this is easiest. So for Q1, we have 5.75. So that is right here. So in this bin, it's going to be 0 to 7. Alright. Next, we have 11.5. Okay. And so that is going to be right here. So this is going to be 8 to 15. And then finally, we have 17.25, and that's going to be the 16 to 23. So that's right here. Alrighty. So good, we have those. Now we have to do the entirety of 9th grade. Alright, so we have 80 people here. And then we have 40 people here. And then we have 100 people here. And we have 80 here. Goodness. So, I don't know about you, but I really don't want to have to write 80 people. So we're going to have to figure out a different way to do this. Alright, but first we're going to add them all up. So 80 plus 40 plus 100 plus 80 is going to give us 300. And we're going to divide that by 4. We always divide it by 4 because we have quartiles. Quart means 4. So 300 divided by 4 is going to give us 75. So Q1 is 75 times 1, which gives us 75. Q2, 75 times 2, which gives us 150. And then Q3 gives us 75 times 3, which is 225. Alright, so for our Q1, we have 75. So obviously that one is going to be in our first bin, because it goes to 80 people. So that's going to be our Q1. Alright, to find 150, honestly what I would do is just do the top number when you get to really large ones. So we know we have 80 people here. Okay? And then, what's 80 plus 40? Well, that's going to be 120. So we're going to have 120 people here. Okay, so no, I haven't reached that one yet. And then we're going to add 120 plus 100 to give us 220 people. There we go. There's our Q2. So So that's going to be 16 to 23 people, because this one only goes 81. Here we go. Let's do this. 1 to 80, and then 81 to 120, and then 121 all the way to 220. And this is going to be 221 all the way to 300. That might be a little bit more helpful. Okay. So then, obviously, our 225 is going to be in the 24 plus bin. Alright, so now we are comparing the medians. So, excuse me. The median, whoops, totally moved. Okay. I'm going to zoom out a little bit so that we can see everything. Alright. So we're looking at our medians, which is our Q2. So Stephanie's homeroom is, take a look at what Stephanie's median was. It was the bin 8 to 15, okay? The whole 9th grade class median. Well, that median was 16 to 23. So this bin was larger. So Stephanie's homeroom is lower or below, because we are comparing bins. Alright, next one. The lower quartile, which is Q1. Stephanie's homeroom was 0 to 7, and the whole 9th grade class was also 0 to 7. So we're going to call that comparable, meaning about the same. But I think the milestone likes the word comparable to the whole 9th grade class. Alright, and then for upper quartile, Stephanie's homeroom is blank the whole 9th grade class. Well, hers was 16 to 23, and the whole 9th grade was 24 plus. Therefore, once again, her homeroom was lower or below the whole 9th grade class. And congratulations, you just compared 2 histograms. Alright? So that's pretty much how you're going to be asked to compare histograms. Alright? So, let's move on. Alright, so for data distribution, this is asking you about the shape of the data. Ooh. Trying to get it somewhat equal looking. That's not even close. It's a little bit better. Okay. So, a normal distribution shows the quantitative data. That vary randomly from the mean, and the pattern follows a symmetrical bell-shaped curve called a normal curve, and it looks something like this. Alright? So, in normal distribution, the median and the mean are the same. Okay? So that's what a normal distribution is. Median and the mean are the same. The skewness is the type and degree of distribution's asymmetry. So if it is left skewed, it has a longer tail on the left side, meaning it could look something like this. Okay? And right skewed means that it has a longer tail on the right side. And also, generally, distributions only have one peak, but there are distributions where this is not true, and peak means like a maximum. Alright, so if we have a bimodal, that means that we have 2 peaks, 2 maximums. Alright, if we have a multimodal, we're going to have maximum peaks. or sorry, this is more than 2 peaks. And then uniform is going to be no peaks. Alrighty. Okay, so then let's try to look at our histograms first, and we're going to determine the first 3, if they are bimodal, multimodal, nomodal, or if they are normal. Okay? So for this first one, just create humps. You would have 1 hump and 2 hump. So this one is going to be bimodal. Alright? And then this one does not really have a hump, so it's going to be uniform. And then finally, this is our bell-shaped curve that we were talking about, because it goes up and then it comes back down very nicely, very evenly. So this one is going to be normal. Alright, and then these bottom 2, we're talking about left skewed and right skewed. So remember, left skewed is when the tail is on the left side. So you see how you have a tail over here? So this is going to be left skewed. And then, for this one, we have a tail on the right side. So this is going to be right skewed. But we can also look at left skewed and right skewed and normal and all that fun stuff for our box plots. That's right, they don't go away. So, right here we have a tail on the left side. So this is going to be left skewed. And so then what do you think the next one's going to be? It's going to be right skewed. Very good, because our tail is on the right. And then finally, when it doesn't look like it is more left or more right, it's going to be uniform. Honestly, I don't think that they have a normal box plot. I just don't think one of those, or at least, yeah, I don't think they have one of those. Alrighty. So that's the end of our notes for today. Good job, guys.